Number 2, please. So number 2, you only got one answer, right? So let's just recap. For a third equation, the variable is the third. You need to isolate the third firstly. So you move that plus 3 over, it becomes minus 3. Then, in order to cancel out the square root, you have to square both sides. Right? You're left with x minus 3. Guys, negative 3 squared is negative 3 times negative 3. Right? So that's positive 9. Okay, so that's not negative 9 there. Just take note of that. You square the whole negative 3. Brackets around that. Then if you move this negative 3 over, it becomes plus 3. All right, so 9 plus 3 is 12. And then you can see I wrote my check down on the side. If you actually sub the 12 in on the left-hand side, you're actually getting 6, but on the right-hand side, it should be equal to 0. So since the left-hand side is not equal to the right-hand side, 12 actually doesn't work for this equation. Remember why does that happen? Because we changed the equation actually when we squared both sides. So we're actually getting an answer that works for this equation, right? The one that we created, but it doesn't actually work for the original. So in that case, I just mentioned it yesterday, but we didn't actually see an example. So just check there. If the one answer that you're getting, or maybe if both of the answers that you're getting don't work, then you need to just end that loop by saying therefore no solution. Okay, so you don't just stop at x not equal to 12, you have to also say no. Right, are there any questions on that first one, right? And then 7 is there. So in 7, guys, it's very important. Remember, when you have multiple terms and you're squaring that, you can't just say it's the first term squared and the last term squared. Right? You have to actually write the bracket next to itself, all right? The 4 minus x, 4 minus x, and then FOIL those brackets out. Because if you just square the first term and the last term, you don't get this minus 4x and minus 4x in the middle. Okay, so you have to FOIL them out, guys. So it might seem like extra work, but you have to do it to get the right answer. Okay, so in the end then, after I FOILed out, I just put my x squared first. I have negative 4x minus 4x, that's negative 8x. Right? And then this is going to become another negative x, so that's where the negative 9x comes from. And then 16, this becomes a plus 2 when I move it, right? So 16 plus 2 is 18. You could have factorized it, or you can use the quadratic formula. It's up to you. It doesn't matter. You would get your 2 answers. I just write my check down, but when I sub in x equals 6 there and there, it doesn't work. Let's just quickly think about it, right? If x is 6, then I'm going to have 6 minus 2, which is 4. What's the square root of 4? The square root of 4 is 2, right? So if x is 6, then this side is 2. But what is 4 minus 6? Negative 2. All right, so I'm getting 2 on the one side and negative 2 on the other side, so they're not the same. Right, so that's why x equals 6 didn't work. But if you put a 3 in there, it actually does work. So 3 minus 2 here is 1. And the square root of 1 is just 1. All right, so we get 1 on the left. 4 minus 3 is also 1. Okay, so we get a 1 there and a 1 there, so x equals 3 does work. Okay. Like I said yesterday, you don't have to write down the check, but you do have to do it either in your head, like I did now, or on a calculator. Or if you want to write it down, it's also fine. It will obviously just take a bit more time. Okay. How are we feeling about these third equations, guys? Okay, all right, okay. All right, there we have number 8. So number 8 is very similar to number 7. The only extra thing is that you have to move that minus x over first before you square both sides. In number 7, that third was already isolated, it was already on its own. So you could square that straight away. So just check for that. Then you FOIL out those 2 brackets. Get all your x's, or get everything on the one side equal to 0. Now I just have left it like this, okay? 0 equals to this. I just wanted to remind you, remember we spoke about this yesterday, that you can actually just split an equation around. If you like having the x's on the side. Then I decided to factorize this one, because I thought it's quite an easy one to factorize. So let's just talk about this factorization quickly. If you're looking at this trinomial, right? You're going to look at the last term. You're going to say, I need factors of the last term. So factors of 4. Because there's a plus in front of that last term, the sum of the factors So in other words, the factors of 4, when I add them together, must give me the number in front of x, must give me 5. Now for 4, let's think. Factors of 4 that when I add it together will give me 5. 4 and 1, right? Because 4 plus 1 is 5. So you could have just done x plus 4, x plus 1. Okay, then you would make each bracket equal to 0 and then just move the plus 4 and move the plus 1. Or, like I always say, feel free to use the quadratic formula. Will give you the correct answer. Then you can see I did write my check for this one. So on the side there, with x equals -4, I got 5 on the left plus 3 on the right. So that obviously doesn't work. And -4 is invalid. And when I sub in -1, you can see that I got 3 for both sides. So that doesn't work. Any question? Look down. If you missed some of the lines there in question 8, you can ask me. For question 12, again, we have to move the x, it's positive x here, right? So it's going to become minus x here. And then guys, remember we did an example yesterday where there was a number in front of the surd. So then I said, don't move that number across, rather square the number and the surd together. Otherwise, you're going to create a fraction, all right? So leave it like this, square that whole thing. What's going to happen there is you're going to have 2 squared, which is 4. And then the bracket, or the x minus 1, the square root squared, which is then just x minus 1. But then you must remember to put that thing that was in the square root must now be in a bracket. Okay? So that's important, guys. Please remember to actually square that 2 and the third. Alright, just check that you have a 4 and then that bracket. And for the next one, 4 minus x squared, you write the bracket next to, well, 1 next to the other one. The bracket multiplied by itself. You FOIL out at the left like terms. Then for this one again, I factorize, but guys, it's perfectly fine. You put the bracket formula with the same answer or answers. And then you can see again, I did my check on the side. 10 did not work, so that one is invalid, but 2 did work. Right, so that one is the answer. Any questions? And we are moving on again today. I'm going to see on Monday, I'm going to give you guys just check. When I see you guys on a Monday, before second break, I'm going to give you a whole hour on Monday just to practice a bunch of mixed questions. All right. So we've been working very much with the whole time. I'm going to give you just that hour to just work on all of these different types of questions mixed together. I'll make a worksheet for you guys. And then on Tuesday, we're going to move on to a new chapter, experiments. Okay. For us today, Wednesday. So today I'm going to do inequalities with you. Tomorrow and Friday, some word problems, and then Monday we'll tie it all together. Okay, so we're done right on time. Okay, guys, new heading, please. Quadratic inequalities. So quadratic, you all know how to write that. But now not equations, inequalities. Does that word sound familiar? You worked with inequalities last year. Do you remember the greater than, smaller than, that symbol? Right, we're going to work with that now. Sorry, I'm also just getting there. So now back in grade 10, you did linear inequalities, right? So where you're just working with an x or a y. Now we're going to do inequalities where we work with an x squared. But before we jump into that, I just want us to do an example of a linear one, maybe two examples, just so that we can remember what we did for those. Okay, so we're just going to say here revision linear inequalities. Okay, again, we are solving for x. Okay, if we have something like 9x plus 4 is smaller than 3x. So that is familiar? That symbol, do you see that now? I'm not saying that 9x plus 4 is equal to 3x. I'm saying that 9x plus 4 is now smaller than 3x. All right, that is what that symbol means. So we can just circle that symbol and just write there smaller than. And guys, that means that we need to find a value for x. And often with these questions, we don't actually only find one value for x, we find multiple values, which now we get the answer. But whatever x is, it needs to be a number so that if I multiply by 9 and then add 4 to it, that value that I get must be smaller than the value, like a number that's smaller than, if I take 3 and I multiply by that x value. Right? So we're not trying to find left-hand side equal to right-hand side. We're now trying to find left-hand side smaller than right-hand side. So if this is 2 and that's 3, for example, right? 2 is another that's smaller than 3. All right, I hope if you remember some of this from grade 10, we are actually going to solve this just like we solve an equation. All right, we're going to move things around. We're going to change the sign if we move them. There's one important thing though. Whenever you multiply or divide by a negative number, the sign must swap around. You remember that? For inequalities, let's just make a note here. When you multiply or divide by a negative number, the symbol must change direction. Okay, that is very important, right? So if we have, for example, a negative x and a 4, and we want to take that negative 1 over, we need to swap the symbol around. Okay, we can't just divide by negative 1 like we did before. We're going to do that, but we need to then swap the symbol. Okay, so this one here, do we notice that we have an x on both sides of the inequality symbol? So this 3x we must move, okay? When I move this 3x, I'm just subtracting 3x. All right, I'm not multiplying or dividing by a negative number. So when I just move the 3x to the side, we're not going to change the sign. It's only when you multiply or divide by a negative number. Okay, so you'll do 9x minus 3x. So you're going to keep that symbol the same. because we're not multiplying or dividing, we're subtracting. Okay, when we change that positive 3x to a negative 3x, we're actually subtracting 3x from both sides. Okay, what's going to happen with this plus 4? When I move it, and it becomes negative 4. Essentially, I am subtracting 4 from that side and from that side. Okay, so I'm not multiplying or dividing by a negative number. I'm working with negatives, yes. But I don't want you guys to think that whenever you put a minus there, now you must change the sign. Okay, so only when you are multiplying or dividing by a number that is already negative. And we'll do an example now for this. It's not when you change the plus to a minus. All right? When you try to divide by a negative number. Okay, 9x minus 3x is 6x, yes? Smaller than negative 4. Now when I move this 6, I'm going to divide by 6. Positive 6, not negative 6. So when I'm dividing by positive 6, do I have to change the sign? No, only when you are dividing by a negative number. So I'm taking a negative number and I'm dividing it by a positive number. Okay, so because this 6 is positive 6, the symbol is going to stay as it is. All right, so x is going to be smaller than negative 4 over 6. Is 4 over 6 the simplest form of our fraction? 2 can divide into 4 and 6, right? 4 divided by 2 is 2, and 6 divided by 2 is 3. So you have to simplify that, guys. The answer is then x has to be any number that is smaller than negative 2/3. Can someone think of an example of any number that's smaller than negative 2/3? Any number. Negative 4, maybe not a fraction. Negative 4 over 5. Might be, right, the fractions is a bit complicated. What about just negative 4? Okay, isn't negative 4 smaller than negative 2/3? Okay, what about negative 10? That's also smaller than negative 2/3. So guys, we actually have a range of answers for x here. Any number that is smaller than negative 2/3. Right? Any number that's smaller than negative 2/3 will give us a number on this side that is smaller than 3 times whatever that x is. Okay. I'll just add here. X can be any number that is smaller than negative 2/3. For example, negative 4, negative 10, etc. Right? You can list a million numbers that are smaller than negative 2/3. And any of those numbers would work. Now guys, last year, there was quite a lot of emphasis placed on different notations, right? Different ways of writing your answer. If you are writing your answer with this inequality symbol, we call this inequality notation. All right, so we're just going to revise that quickly. This, when you have the actual inequality symbol, so the little arrow thing, this is inequality notation. So we just write it underneath. And usually in grade 11, they don't specify. I know in grade 10 they did. They usually told you write your answer in whatever notation, but that's because it was new. They wanted to test you. All right, in grade 11 and 12, normally any notation that you want to use is fine. Unless they specify that they usually do. Can anyone remember another type of notation? Okay. The number line, yes, number line notation. Do you remember that? Okay, so let's do number line notation quickly for this. So you can just draw a line. Now guys, our answer only has one value in it. All right, we'll do an example now where we have 2 values in our answer. But here the answer only has 1 value in it. So that's the only number that you're actually going to put on your number line. Negative 2/3. Now we're going to indicate with an arrow which way we're going. Right? Firstly, can x be equal to -2/3? No, do we all see that there's no line under the symbol? Okay, if there's no line, means that x can't be -2/3, but x can be anything smaller than that. Okay, so we're going to put an open circle above -2/3 to show that it can't be equal to -2/3. Now guys, it has to be smaller, right, than this number. Are we going to go to the left or to the right? To the left, right? So you just take your ruler again and draw a line to the left with an arrow. That is indicating that any number that is smaller, any number that is to this side of -2/3 will work. Okay, this is number line notation. Now, when we get to quadratic inequalities, which we'll get to later, okay, we are actually going to use a number line to figure out our answer. Okay, so we're going to get much more practice in number line now. Then there was one last type of notation, which we call interval notation, which we use brackets for. Right? Does that sound familiar? So for this, you're going to use that x is an element of, and then you're going to put in brackets from which number to which number. Right? And you're going to use round brackets if the values are not included, square brackets if the values are included. So guys, it can be any number smaller than -2/3. Where does that end? So it can be -1 million, but it can be -2 million, it can be -10 million, it can be -1 billion. Where does that end? Negative infinity. Good. Alright, so if it's smaller than a number, but there's no actual boundary, we say it can go to negative infinity. But guys, negative infinity doesn't really exist. Okay, it's not actually a number, it's more like a concept. Just understanding that it can go on forever and ever. So we can't use a square bracket for that. Right? Because it won't actually ever be negative infinity. Whatever number you say, you can always find a number that's smaller than it. Okay, so we always use a round bracket for infinity or negative infinity. And then it can go to -2/3, but can it be equal to -2/3? No, so we again use a round bracket. This is called interval notation. Okay, so those are the three notations that you spent time on last year. But like I said, it's actually fine if you just leave your answer like this. Some people prefer writing answers like this. All right, maybe when we get to other work, when we're doing functions and graphs and stuff, some people prefer working with the brackets. Okay, but it's fine if we just leave it like that. Right, let's look at another example now where you actually have two values in your answer. So I'm talking about this type of question. Let me just get a nice one here. One and then smaller than equal to x3 and then smaller than 5, like that. Okay, so the x -3 is in the middle, and we have a -1 on the one side and a 5 on the other side. All right, you guys remember that you work outwards, okay? So whatever you do on this side, you also do on this side. The reason for that, guys, is because you could actually split this up into two separate inequalities if you wanted to. So you could split this up into just that part, right? So you could say -1 smaller than or equal to x -3, right? You could just look at that one on its own. And then at the same time, you could look at the other side. You could say x -3 has to be smaller than 5. Right? When they put two inequalities together, like they have in the question, you're actually solving two at the same time. Right? You're solving the left-hand one, and then you're solving the one on the right. But you are allowed to do them at the same time. Okay? If we're looking at these two, do you agree that we have to do the same thing with the -3? If I move this -3, I must add 3 to the -1, right? And here, if I move this -3, I must also add 3 to the 5. So instead of doing two separate inequalities, we're doing the same thing anyway. You can just do it to both sides. All right. So I'm actually going to write that here. I'm going to say -1 plus 3. And on the other side, you are also doing 5 plus 3. Okay, so everything that goes from the middle needs to go out to both sides. All right, because it's actually two inequalities in one, as you do. So -1 plus 3 is 2, right? And we have that symbol, and then smaller than 5 plus 3 is 8. So now this is saying, guys, that x has to be, if we're reading it from the x out, x has to be bigger than 2, right? Do we see the bigger part of the symbol is pointing towards the x, the open part? So x has to be bigger than 2, but it can also be equal to 2. Do we see that in this one? And then at the same time, x must also be smaller than, because the smaller point is now towards x. X must be smaller than 8. So x has to be bigger than 2, but smaller than 8 at the same time. So for example, 3. All right? 3 is a number that's bigger than 2, and it is smaller than 8. Can it be 9? 9 is smaller than 2, right? But is 9 small? Right? 9 is bigger than 2, but is 9 smaller than 8? No. So it won't be. All right, so whatever x is here, it needs to be bigger than 2. It can also just be 2, but then also smaller than 8 at the same time. All right, so for our number, right? Now, because the answer has two values in it, we're going to indicate those two numbers, the 2 and the 8. Since x can be equal to 2, we're going to do a closed circle above 2. That indicates that 2 is included in that one. And it can't be equal to 8. It has to be smaller than 8, so we do an open circle above that one. And then it's any number in between the two, right? So to show that, we're just going to take a ruler and join the two dots. And that is showing that it's just any number between 2 and 8. It can be equal to 2, but it cannot be equal to 8. Yes.
So could we just leave the answer in that?
Yes, perfect. Yeah, I'm just revising the other notations. But yes, there you would get 4 marks in that. Okay, let's just quickly revise how we would write this in interval notation as well. You would say x is an element of, now guys, am I now going to include negative infinity or positive infinity in my answer? I actually have two different boundaries. Okay, it must be between 2 and 8. So for 2, 2 can be included, so we're going to use a square bracket for our 2. Semicolon, the other boundary is 8, but 8 is not included, so for that one we need to use a round bracket. Okay, but again, you could have just stopped there, you just revising the definition. And going forward, you'll see that I'm going to use all my answers like this. Okay, if you want to do the other notation, you can ask me what that would look like, but you don't have to. Okay, let's move on to quadratic ones. So guys, when we are doing quadratic inequalities, unfortunately, just like quadratic equations are more complicated than linear equations, it's the same with inequalities. All right, so we are going to do them slightly differently. So now we are not doing revision of linear inequalities anymore, so I'm just going to write here quadratic inequalities, just to show that we are now actually doing those. Again, it's just going to ask us to solve the x. X squared minus 9 greater than 0. Okay, for a quadratic inequality, the first step is going to be the same as for a quadratic equation. Right? You are also going to get it in standard form first. Okay? So what I mean by that is everything on one side of the inequality symbol and 0 on the other side. Okay, so that is the first step. So we are going to get it in standard form, which we remember is ax squared plus bx plus c. Now it's not going to be equal to 0. I'm going to put it equal here, but remember it's actually going to be a smaller than or a greater than, or they can put lines underneath to show that it's equal to as well. All right, but basically everything on the one side and a 0 on the other side. Okay, that's what you need to get. You see that in this case, they've already done that. Right? Now let's from here, you are going to, for the next step, treat this as if it's an equation. All right, it's an in-between step. Not going to get us to our final answer yet, but the second step is solve for x as if in an equation. But the important thing is we are going to label this as CV. Okay, so what I mean by that is we're going to say CV, I'll explain now what that is. We're going to physically write CV x squared minus 9 equal to 0. We're going to figure out the smaller than or the greater than thing after we've now actually solved it. Okay, so this is an in-between step. Guys, please highlight that CV, underline it, circle it. If you don't write CV, then you're going to get 0 because they're going to think, oh, you know what I'm saying, this isn't equal to 0 and you're solving for it. Okay, you have to label it as CV, please. Now, CV is short for critical values. We are going to talk about critical values quite a lot going forward in this grade. So I'm just going to make a note here at the bottom. CV stands for critical values. And critical values is literally values where the equation is equal to 0. Right? So values where, no, I'm not going to say equation, I'm going to say expression. The values where the expression, in this case, the expression is x squared minus 9. Okay, so values where the expression is equal to 0. That's what a critical value is. And now we're going to use the critical values on our number line to actually figure out what our final x values must be. Okay, so it's important that we find the critical value. So this requires a bit of a mind shift. Okay, it's completely different to what we've done so far. Quadratic inequalities is different to the stuff that we've done so far. Okay, so I don't want you to panic and think, oh, I don't know what's going on. It is new. All right, so just bear with me. So I'm going to go through that again. The first thing is you need to get it in standard form. So just the 0 on that side, it was already given in that form. But if that 9, for example, was over there, we would have to move it across. Okay. You have to always have everything on one side and then 0 there. Then step 2 is you write CV and you write whatever you have on the left equal to 0. So you replace whatever that symbol was with an equal symbol. And now guys, you're going to solve for x in this equation, however you want to do it. All right, you can factorize and get your 2x values, or you can use the quadratic formula and get your 2x values. All right, is it fine if you guys can factorize? The difference of 2 squares, can we practice that? Okay, do we see that this is not a trinomial, right? There's no x term in. There's a difference of 2 squares, so I'm going to say x plus 3, x minus 3 is equal to 0. Right, remember when you're factorizing a difference of 2 squares, you take the square root of each of those terms. Right, so the square root of x squared is x, The square root of 9 is 3. We put a plus in one bracket and a minus in the other bracket. Now we have two brackets multiplied together equal to 0, right? So now we need to make each of them equal to 0 separately. So guys, we're just solving for x as we always do. Okay, but we're going to do extra work afterwards because it's actually an inequality. So here x is negative 3 or x is positive 3. Okay, so that is step 2, right? Step 1, get it to standard form. Step 2, solve for x as it is an equation. So these are now our two critical values. Step 3 is you are now going to draw a number line with those critical values on the number line. Okay, so you're just going to take your ruler, just like we did earlier with number lines. You draw a line, you put the smaller number first, so negative 3, the bigger number next, positive 3. All right, so that is the next step. Draw a number line indicating the CVs, the critical values. Now, guys, we need to just go back up to the actual question, all right? Remember that these critical values are values of x. Okay, when we solved here, we got that x is negative 3 or x is positive 3. But guys, that's not the answer to the original question. The original question is asking, what does x be for x squared minus 9 to be bigger than 0? Right? Bigger than 0. Do we agree that if a number is bigger than 0, it's a positive number? I'm going to say that again. If a number is bigger than 0, right? Here we have our number line, there we have negative numbers, 0, and we have positive numbers. If a number is bigger than 0, it's positive, right? So I'm going to rephrase that. There are going to find values of x that will make whatever that number is, if I square it and I subtract 9, then I get a positive answer. Right? Greater than 0 means positive. Just add that there. It can be any positive answer, guys. It doesn't matter what it is. Anything that's bigger than 0. All right, so it can be 1, it can be 2, it can be 20, it can be 100. Right, we're looking for any positive number. So what I'm now going to do, I'm going to look at this number line. Do we identify that there are 3 sections to this number line, right? If I'm looking at this section, those are all numbers. So if I'm looking here, those are all numbers that are smaller than negative 3, right? What is that? Any number or all numbers that lie between negative 3 and 3. These are all numbers that are bigger than 3, right? So there are 3 sections on this number line. Yeah. There are 3 sections on this number line, so we are going to choose one number in each section. Okay, are we paying attention? We're going to choose one number in each section of this number line, substitute it into this x squared minus 9, and see where do we get a positive answer. I'm going to write that down because it is complicated. Choose one number, it can be any number in each section, one number in each section of the number line. Right, like I said, it's completely different from anything that we've done so far. So don't worry, it's the first example. If you are confused, that's fine. We're choosing one number in each section of the number line. Sub that number into x squared minus 9, or whatever that expression on the left is. Okay, for this one, it's x squared minus 9. And indicate whether the answer is positive or negative. What do you mean? So I'm not going to sub in -3 or 3. I'm going to sub in a number that's smaller than -3, and a number between -3 and 3, and then a number that's bigger than 3. Okay, so these two critical values that we get are actually splitting the number line into 3 sections. I do agree with you. If we subbed in these two, we would get 0 for both of them, right? But remember, we're not supposed to say where it's equal to 0. We're supposed to say where it's positive. Okay, so we're using these two numbers as like a guidance. Okay, now guys, we're going to write down the next. You don't have to write down in the test exam, but let's all write it down so that we remember next time what we're actually doing. Let's choose any number in this section, any number that's smaller than -3. Can we go with -4? We agree that -4 is smaller than -3, right? You got -3, -4, -5, -6. Okay, so let's say we are making x equal to -4. Guys, you can choose any number. You can choose -5 if you want. You can choose -10, -100. Any number that's smaller than -3. Okay, it's completely up to you. In fact, you're not even going to show me that working in a test exam. I'm not going to know which number you chose. Okay, this is just because it's the first example I'm just showing you. So if we have x equal to -4, what is this going to be equal to? We're going to have x squared is now -4 squared, right? Minus 9. Now what is -4 times -4? 16. 16 minus 9 is 7. Is 7 positive or negative? Positive. So now in the section just above it, please make a plus. Right, it doesn't matter which number you choose that's smaller than -3. If it's any number smaller than -3, you will get a positive answer. Okay? Now let's choose a number between -3 and 3. Let me just actually make a plus here next to this, so that you know that is what we're looking at. I'm not worried about what that number is. You're not writing 7, you're writing plus or positive. Okay? Can we think of an easy number between -3 and 3? What about 0? You can do 1 and 1, so 1. Okay, yeah, let's go with 1. X equals 1. That's fine. So remember the inequality that we're trying to solve is x squared minus 9. So we're subbing it in there. Okay? So we're going to say 1 squared minus 9. What's 1 squared? 1 minus 9 is -8. Is that positive or negative? Negative. So on my number line for this section, I'm going to put a minus. And that means that any number between -3 and 3 will give me a negative answer. If I square it and then subtract 9. Okay, now we're going to look at the last section. Any number bigger than 3 is going to go with 4. Right, positive 4. Again, we're taking x squared minus 9. So if we do 4 squared minus 9, we're going to get 7 again, right? 4 squared is 16. Minus 9 again is 7, which again is positive. So we're putting the plus on the number line. And whether the question was asking for smaller than 0 or greater than 0, you would do exactly the same thing. Okay? Doesn't matter whether the question was asking for greater than 0 or smaller than 0. You still solve for x as if it was equal to 0, but you have to name the critical values. You draw your number line, and you test your 3 sections. Now we need to decide, what was the question asking for again? Positive. Where does, or in which sections do the x values give me a positive answer? In those 2, right? Please circle those or highlight them or something, and you have to also indicate that on your number line in the test breakdown. So you can circle those pluses, you can highlight them. I now need to write that in maths terminology. Okay? I can't leave my answer like that. So here we said any x number, any number that's smaller than -3, right? That's how we chose -4. Any number that's smaller than -3 will give us a positive answer. So how are we going to write that? Therefore, x must be smaller than -3, right? X smaller than -3 represents this section of the number line. So there we have -3, and we tested a number that's smaller than that. Okay, so for any number where x is smaller than -3, it will work. But there's a second part in our answer as well. Yeah, where x is bigger than 3, right? So you have to put or, just like we did with the equations, where x is greater than 3. You can, but you don't have to. But you can if you want to. And that's it, guys. That's the answer. Okay, so that is saying that any x number or x value smaller than -3 will make x squared minus 9 positive, or any value that's bigger than +3 will make x squared minus 9 positive. Okay, that's what that answer is. So guys, in a test or exam, or just even in class, when you are practicing this, you're obviously not going to write down all of these steps on the side, right? And this you also don't have to write. So let me just put that on the side there. Your actual substitution, you don't have to write. You can just use the calculator for that. And again, you can just use the arrow button to make things easier for us. So say, for example, for your first one, you typed in -4 squared minus 9, right? -4 squared minus 9, you get your 7, okay, which is positive, so you just put your plus there. Now you choose a number between -3 and 3. We said we want to go with 1, so you just use your arrow to clear, sorry, the -4. You put a 1 in there, you get -8, you just put your -6. Now we want a number that's bigger than 3, so you just use your arrow button to clear the 1, we change it to a 4, you get +7, so you put your plus there. Okay, so instead of writing this down, you can just use your calculator for that. Okay, it will save some time. So I'm just going to write on the side here. Don't have to write. But again, if you want to, especially when you're doing like exercise questions on this, you can. Now guys, if the question was x squared minus 9 smaller than 0, so it's the same inequality essentially, right? It's again x squared minus 9. Now I'm actually going to show you what you need to write down for this. Okay, so x squared minus 9, you're going to say critical values. Okay, you're going to do that whole thing again. Blah, 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 equal to 9, factorize, get your answers. All right, so you would write, for example, x squared minus 9 is equal to 0. So x plus 3, x minus 3 is equal to 0. It's the same one as the previous one, okay? That's why I'm just going through it quickly. You would factorize it, because it's a difference of 2 squares. You would make each bracket equal to 0. From the first bracket, you're going to get x equals -3. From the second bracket, you're going to get x equals +3, right? And you make both of those brackets equal to 0. You're going to draw your number line. You're going to put in your -3 and then your +3. You're going to choose your number here, sub it in, get a positive answer, so put a plus. You're going to choose your 1 or your 0 or your 2 or your -1, your -2, whatever you want to choose in here in between -3 and 3. You're going to get a negative answer. You're going to choose your number that's bigger than 3. So you're going to choose 4 or 5 or 6 or 7 or 8 or 9 or 10, whatever you want to choose. You will again get a positive answer. Remember, it doesn't matter what that answer is. Okay, so guys, you see now, compared to what we wrote down the first time, we're writing down much less now. Okay, I'm actually showing you what you need to write now. Now you're going to look at this, at the question. Now it's saying smaller than 0, which means negative, right? If a number is smaller than 0, it's a negative number. So now we are looking for negative on this number line. So now we're going to circle the minus. So now we're going to say that if x is any number between -3 and +3, right? That's that section. Between -3 and 3, it will make this whole thing negative. So now for your answer, you're going to say, therefore, -3 and x and +3, right? So x has to be between them. And then you just need to make sure that you put your, it will always be pointing to the left. All right, but if you're reading from the inside out, x is bigger than -3, but at the same time, x is also smaller than +3. Okay, you need to be able to read it from the inside going out, and it has to make sense. Right, so if we're looking at all of these numbers, do we agree that these numbers are bigger than -3, but at the same time, they are smaller than +3? Okay, so your answer needs to also read that x is bigger than -3, but smaller than 3. Okay, and that is then your answer. All right, guys. I'm actually not going to give you homework. I'm rather going to let you guys practice some of these tomorrow. For the first half hour, the second half hour, we'll start working on some basic word problems. Okay, so no homework for today. Maybe just read over these 2 examples when you add homework, just make sure that it makes sense to you, because tomorrow you're going to go straight into practicing some on your own. Okay. Back up, please, guys.